Hi everybody, this is Mrs. Ellsworth, and what we're going to be talking about today is again the Bohr model, but we're going to be adding the idea of ions onto it. So let's go ahead and start this discussion. Have you ever heard, on the periodic table there's fluorine, and I know you've heard of fluoride. Okay, that is an ion. And then there's magnesium, and then the magnesium ion. So how we name these and how that we worry about the Bohr model shape, we're going to discover that right now. Okay, so let's go ahead and start with this. For an ion, it's a charged atom. An ion is a charged atom. And what does that mean? That means that it either lost or gained electrons. You see, an atom never loses or gains protons. I mean, there's another situation called an isotope where they gain neutrons, but we're not going to worry about that today. An atom never loses protons except for when it's doing radioactive decay, and that's another subject a long way down the road. But an ion will lose or gain electrons. The protons always stay the same because as soon as an atom loses its protons, it loses its identity. That is how we go and identify every single atom, is by the number of protons that it has. So the only thing that we'll be talking about is whether it loses or gains electrons, because that will make it a charged atom. Okay, think about it. If you lose electrons, what's going to happen is that you've got more positives than you do negatives. So that means that you're going to have a positive ion. So when you're doing your Bohr models with ions, keep this in mind. Okay, if it's a positive ion, it'll lose electrons. Okay, think about that. You had the same number of protons as electrons, and it goes and loses some of its negative charge. So you still have more positives. Okay, now if your atom goes and gains electrons, okay, if it gains electrons, then hey, you had the same number of protons, same number as electrons, and then what do? You add more electrons, so you get a negative ion. Okay, and so these have special names. The positive ion is a cation, and the negative ion is called an anion. Okay, and you might recognize those beginnings for a cathode and anode on a battery or a different charged component in an electrical system. And it's about that, which one's negative and which one's positive. It helps me to remember these if I go and I remember that this T looks like a positive and N is for negative. Okay, and that's just on the first three parts of the prefix that helps me recognize that. Now these also have special names. Okay, and so then the special names for the positive ion, we actually just use the name and then we put ion on it. So name plus ion. Okay, the name and ion. Like magnesium ion, calcium ion. Okay, if it is a negative ion, an anion, then it has a total change on the suffix of it. So that's why fluorine went through and put fluoride. That's why we've got chloride. Okay, other ones would be like sulfide, oxide, nitride, bromide. So those type of words right there are for negative ions. So when you're looking at your Bohr model worksheet, if it's got ion on the end of it, that means it's a positive ion, so that means you're going to lose electrons. Let's try a couple of these so that you feel more confident in what you're doing with your worksheet today. Okay, so let's go ahead and look at. Okay, I went and grabbed a periodic table here. Let's go ahead and look at this chloride. But let's first of all remind ourselves what chlorine looks like. Okay, so on the periodic table, chlorine. Chlorine has got 17 and 35. So what I want you to do is I want you to pause this video here quickly, and I want you to draw out the chlorine atom. Atom, not ion, atom. So go ahead and do that. Okay, when you calculate the protons, electrons, and neutrons, of course, the smaller number equals your protons. And your electrons is equal to that when it's an atom because it has a neutral charge. Okay, and then what do you do to find the neutrons? You go and subtract these two. So in my nucleus, I've got my protons and neutrons. I've got 17 protons, 18 neutrons. When you're writing these out on your sheets, make sure that you include all the labels. Even every single one of these rings, put the little E. Okay, so to continue here, the electrons first fills up 2 in the first energy level. Then it spills over into the next one. We've got 17 that we need to get. So then 8 more fill up. That's the maximum number that one can hold. Okay, then you still got 7 left because this is 10. There's 7 there. And so we'll put 7 in the outermost shell. Remember, the outermost shell could be incomplete. The inner ones will never be incomplete. So let's go ahead and look and double check our work on this. We've got 3 rings on this. 1, 2, 3. And then we need to go over how many spaces? Well, however many are in the last energy level. So 1, 2, 3, 4, 5, 6, 7. So that's correct. Good job. Okay, now let's talk about chloride. Okay, chloride is going to have a -1 charge. Everything in this column will be a -1 charge. So you need to mark this on your periodic table here in a little while when Mr. Lilligren passes it out. And then we've got a -2 charge on all of oxygen's family, -3 on all of nitrogen's family. And so if I say chloride, then you would just look this up, straight up, see -1, and we don't write ones in chemistry, so there we go. Okay, all the positive ions over here, +1, +2, +3, and a +4 for the carbons group. Those of you who have had me before, you know we've talked about these before, these charges, and how that we obtained it. But for right now, we're just going to say anything in this group will have a +1 charge, anything in this group will have a +3 charge, okay, and then -3 for anything in nitrogen's group, and so on. Okay, so chlorine is now being changed to chloride, and so now we're going to go and write this one's electron configuration here. And so we'll do 17 here. So it's pretty neat. You've got 17 because the protons never change. Okay, so protons equal 17. You've got the electrons, they equal 17. But we've gained an electron. Okay, so we need to add one here. So it'll have 18 electrons in this case. Okay, and then we'll have again, we'll have the same number of neutrons. We'll subtract these two and we will get 18. Okay, again, there's an extra electron here. So we need to add one more to that. And so we had 18 electrons. Now think about this. You've got 18 negatives. And we've got 17 positives. So what's the net charge of all this? A -1. There it is. Okay, so you'll have the same exact thing that you did before. You'll have 17 protons and 18 neutrons. Okay, and you'll have 2 electrons in the innermost shell, 8 in the next. Okay, and you still need, you need to have 8 more electrons for right there. Now, when you go and double check up here on the periodic table, it doesn't work. But you'll usually find that you'll get a full shell when you do go and check. So now we're adding one more electron to it, so it'll look like argon's electron configuration. But the electrons are the same as argon's, but guess what? That proton is what describes which element that this is. So don't worry about, because this now looks like it's going to be a noble gas configuration, or at the end of the periodic table, you're just fine. That's perfect because ions do that. Okay, let's go ahead and look at another one. Let's look at rubidium. Here it is, rubidium. Okay, rubidium is number 37. Let me look on the big periodic table here. it has got 86. Okay, for its atomic mass. So go ahead and figure out the PEN. Please press pause here so the students can figure that out. Okay, I did my subtracting. Here we go. Protons equal 37. Electrons equal 37 also because it's just an atom. It's not an ion. And then the neutrons equal 49. I subtracted 86 from 37 from 86, and that's what I got. Okay, so let's figure out this Bohr model. Okay, we have inside the nucleus, we've got what? So figure that out and then write down all of your electrons in there, and let's go and take a peek at that. Press pause, please. Check it out. How does yours look? What did I do? I put my protons and my neutrons in here, and then I went, I know I've got 2 in my first shell, 8 in my second shell, 8 in my third shell, 18 in my fourth shell, and then 1 left over. And then I went and double checked, added those all up, and I got 37 electrons. Not 49. Okay, so let's talk about the rubidium ion. Okay, that's what it's called. Because positive ions say their name plus ion. Okay, and what's its charge? It is a +1. Look straight up. What is it? It's a +1 charge. So rubidium is 86 and 37, and it's a +1 charge. So let's think about our PEN. Okay, so protons is going to be the same exact as it was up there. Okay, electrons, oh, we got to think about that. Because the definition of an ion is either loses or gains electrons, so that's the only thing we change when we find out it's an ion. And so it's lost an electron. It's lost a negative charge, so it's positive. You can go look in your notes to help you on these to double check that, but it has lost an electron if it is positive. So it will be 36 electrons. And then the neutrons, we have to subtract those still. We got the same exact value of 49. Okay, so how will this change? It's going to lose this electron. Now I forgot to tell us something else here, so I better get to that real quickly. Okay, so if I got rid of this electron there, okay, I'm going to erase this because now we're talking about the rubidium ion, and to save some time here because I'm going to run out. Okay, so right there is the rubidium ion. I forgot to tell you that you need to put brackets around it. So we'll put brackets around this and put its charge on. I need to go over and do that chloride on there. Okay, and this is going to have a +1 charge. This is like units. If you forget to put units on a problem and you get it wrong, it just makes you so mad. And this right here is something that has been a problem of mine as long as I've been doing these. So an ion has to have these brackets around the whole thing, and then its charge. So let's go back and fix that chlorine atom, chloride ion, I should say. Oh, for Pete's sakes, where did I put it at? What? Let me go find it. I can't find it. Oh, I erased it. Oh. Anyway, and that chloride ion that we had, go back up in your notes, and we had all that all set up in there, right? And we had gained an electron, and don't forget to go up there and go mark it as a negative charge, a net negative charge of everything that it was. So sorry about that. Oh, great. Here I've got that mistake, and I'm going to publish it on YouTube. Oh, well, you guys have a worksheet that Mr. Lilligren is going to pass out along with a periodic table. And so work on that worksheet now until the end of the period, and I will see you on Monday. Bye-bye.